Twin Control is a European project which aims to develop a new concept for machine tool and machining process performance simulation. The objective is to generate a digital twin of the machining process and use it in process optimization and machine tool design. With recent developments, we can do online simulation too. Online simulation and measurement will benefit the machining community immensely. By integrating virtual machining simulations with measurements, we can do process diagnosis and model-based control. We organized the virtual machining and optimization workshop in Sheffield. The aim of this workshop was to discuss the history and future of virtual machining, present the status of existing virtual machining capabilities, and share what has been developed in the Twin Control project.
Today we got together about 8 speakers from 8 different companies who are involved in virtual machining in some way. We talked about how we use virtual machining and how we're working to develop new capabilities for virtual machining.
We equipped about 12 use cases all over Europe with our monitoring hardware, and so we are able to monitor up to 24 different real-time signals with a sample rate of 10 milliseconds. And these data are really important for our partners to develop simulation, modulation, and to do all the stuff we are trying to do in Twin Control.
The current problems what customers and the factories have, that they just get 2D plots, just basically charts of lines, and they have no clue how that data may be mapped on the surfaces that they get in the end of the result. With our technologies, they're able to visually inspect the final result and immediately see whether the quality is affected or not.
Samtec was a small Belgian PME that was bought by Siemens, and Siemens, as you know, is active a lot in the field of machine tools and machine control. So it's important for us to demonstrate that our tool, our Samtec tools, can be used in this field, and that's, I think, the main interest of our company to join this project, and also to show the possibilities of our software to the partners and to the companies that are around those partners.
With Twin Control, we have gained great knowledge about the digital manufacturing field and the developments that are being done in the manufacturing community. Okay? And we expect to apply these developments and this knowledge in future projects and future activities.
What we're seeing here is a measurement of the force acting on the workpiece. So we calculate how that tool is interacting with the workpiece here. So we have some engagement zone on the tool, and we can take those calculated forces and compare them with true measured forces from the machine in real time.
As we have demonstrated, the Twin Control project has expanded the capabilities of existing solutions and developed new solutions for the machining community. In the next 5 months, we will be implementing these developments on the 2 case studies in aerospace and automotive sector. After demonstrating the impacts in these 2 case studies, we are looking forward to working with any companies who are interested in applying Twin Control solutions in their processes. For more information about the project, please visit the Twin Control website, twincontrol.eu.